Good evening, one and all. In today's lecture, we will see two important concepts. One is multi-threading, which we have seen as an introduction in the previous lecture, and another concept called as exception handling. Both are used to create efficient software using Java. So let us continue with multi-threading. As I said, multi-threading is used to carry out certain number of processes almost simultaneously. Okay, almost simultaneously, so that there may be no delay in executing one of the processes and maybe only one process is getting executed. That should not happen. For example, our video players, the timer increases simultaneously, the progress bar increases simultaneously. We can increase or decrease the volume at the same time. We may minimize or decrease the size of the video or something like that. Means many processes can be carried out simultaneously, and usually one process will not make the other process wait. That is our main motive. So to begin with multi-threading, a thread is a tiny program running continuously or based on how much we want it to run. It is sometimes called a lightweight process. Now, I have already mentioned that there are two ways in creating a thread in Java. One is by extending the thread class, and the other is by implementing the runnable interface. Means what? You already have a thread class with you, which has been provided by the Java developer. Thread is a class, it is the name of a class. And you have your own class, and the methods of that particular class, you want it to act as, you want to put it inside the particular methods. Means whatever functionality you want to perform, you want to implement, that you will put inside particular methods, so that the functionality that you want to implement is carried out with the help of a thread. Okay, so that we will see now how to do it in a program. So there is a thread class and there is your own class, your class. So your class should be a child of the thread class. That means your class is the derived class and thread class is the base class. Similarly, if you are using runnable interface, then runnable is the name of the interface, which is again available with you. It is ready-made, provided by Java developers. And your own class should be a child of the runnable interface. So tell me, on the left hand side, I've written thread and your class. So if you want your class to be a child of the thread class, what should I write? How can I tell that your class is a thread of, yeah, is a child of thread class? What keyword I should use? Should I use extends or should I use implements keyword? Which keyword to thread is a class and my class is also a class. So I want to create inheritance between these two. So which keyword I'll use? Extends or implements?
Extends.
Extends.
Extends. Okay, it is already written over here, right? Extends. So for interface, runnable is an interface, and my class has to be a child of runnable interface. So my class implements runnable. Okay, and the functionality that we want to implement, that will always be written inside a run method. Okay, there is a run method. This method is available inside the thread class and inside the runnable interface. This run method is present in the thread class as well as runnable interface, and you have to override this run method. Overriding a run method means inside the run method you will put your own customized definition. Means you are going to change the definition. That is what we have seen all this time. Overriding means what? In the parent the method is there, in the child the method is there, but what is inside that method in the parent and what is inside that method in the child may be different. That means always the child version of that method gets executed. That is why whatever we write inside the run method, that will get executed. That will override the already existing run method. Is it clear up till now? Yes.
Yes.
Yes. Now there are certain thread methods as well. Okay, now let us see a program first and then we'll get back to this presentation. So if we are using the thread class, then we know that in our program there should be minimum two, there should be our own class, that is my thread one. Okay, this is one class, my own class, this name I have given, and it will extend from the thread class. Okay, so usually you'll get to see minimum two class names. One is your own class and one is the thread class. This thread class you don't have to define. It is already ready, available for you. And you're going to override the run method. So inside the run method, what you'll write, whatever code you want to execute through a thread, that code you will write inside the run method. For example, for 5,000 times, you want to print something. What you're going to print, my thread is running for cooking, happy cooking. And I value will get incremented. Initially it is 0, then it will become 1, 2, 3, 4, up to which value I will go. Can you tell me? Which is the last acceptable value of I according to this while loop?
4999.
Yes, 4999. Okay, once I becomes equal to 5,000, loop will break. Okay, so why I'm running this while loop so many times is because I want to show you that how the threads are going to execute. Inside a thread, you can put whatever process you want. This is just an example. Now this is one class, my own class, my thread one. I want another class, my own another class, that is my thread two, and that should also be a child of thread class. Okay, so two children and one parent, that is possible in inheritance. Parent is thread and children are my thread one, my thread two. Inside my thread two also same thing I have to do. I have to override the run method. And this logic can this code can be different. Okay, not necessary while loop for 5,000 times. You can write anything inside the run method. Okay, but for demonstration I'm using this, and this time what I'm going to display using the run method, my thread is running for writing, happy writing. Okay, so first thread, thread one, that is my thread one class, that is used to display happy cooking, and my thread two class is going to display happy writing. Okay, so there are two classes which I have defined, and both are children of the same parent, thread class. Now, if you want to create the threads, if you want to implement multi-threading, there are basically few steps that you need to follow. So the first step is, just a minute. So these are some of the steps. The first step is you have to make your class as the child of the thread class. Next step is override the run method. Okay, these two steps we have done. Third step is create an object of your class. Your class means child class. So I have created it, test t is equal to new test. I have created the object of my class. And now I have to call a method which is available in the thread class. Now thread class has this method called as start. So can the child access this method start? Will it run properly? Is it possible? The start method is in the parent class and the object is created of the child class. That is T. The child class object, can it access the parent's properties? Is it valid in inheritance?
No.
Why no?
Yes.
It is valid, right? Till now we have seen in inheritance, parent and child. Child can access the properties of the parent. Then it should be a yes, right? You're creating an object of the child, and using the child, you're accessing a method which is defined in the parent. Okay. Is it clear?
Yes.
Yes. So these are the four basic steps if you are using the thread class as the parent. So same thing we are going to do now. We have completed step 1 and 2. Step 3 is what? Whichever classes you have defined, which are the children of the thread class, whichever classes you have defined, which are the children of the thread class, create their objects, T1 and T2, of my thread 1, my thread 2 class. And for both these objects T1, T2, call the start method. So if consider multi-threading is not applied for now, then what will happen? First of all, the start method will be called for the T1 object, and after everything is over, then the start method for T2 object will be called. After the start method for the T1 object, all that execution is over, only then the start method for the T2 object will be called. Am I right? Yes?
Yes.
Okay. But in multi-threading, what happens, as I told you, a process is composed of threads, and the threads have to run almost simultaneously, or you can say concurrently. So what will happen? A little part of the thread will execute for object T1. That means T1.start will execute for some time. Then T2.start will execute for some time. Again, it will go back to T1.start. Again, it will go back to T2.start. Again to T1.start. Again to T2.start. And this will keep on happening as long as something is available for execution. Once all the statements are executed for this T1.start, then it will stop. And if anything is remaining for T2.start, that will happen. And once everything for T2.start is also over, it will stop. So this switching between the threads, first for T1.start, then T2.start, again T1, again T2, this switching will happen as long as there is something for execution. Once all the statements are over, it will stop executing. Is it clear how it will execute? Yes? Yes or
Yes.
no? Hmm. So I'll run this and show you, then maybe you'll understand better. So see here, what we were doing, 5,000 times we were printing happy writing, and 5,000 times we were printing happy cooking. Now, if I, first of all, I've called T1.start, and then I'm calling T2.start. So what is written inside? Now also remember, if I'm saying T1.start, the start method is responsible in order to execute the run method, which I have overridden. Okay, what did I say? The start method is responsible to call the run method. Okay, now why this is so is because if you directly now we know that there is a run method that we have overridden. So why should I not call T1.run? Why don't I do T2.run? This is because if you simply do T1.run, then the run method will be called as a normal method. It will not be called as a thread. But once you say T1.start, the start method will internally execute the run method. And if you're calling the start method, the run method will be executed as a thread. But if you call only the run method, T1.run, then it will execute, it will get called as a normal method. But when you do T1.start, it will execute run as a thread. Okay, now why it happens is because this start method, how it is defined by the developer, that I'm telling you now. So there is a start method, whatever it is, public, void, whatever. It may be anything. This may be public, whatever, and this also returns something or no, that is dependent on how it is developed by the developer. Okay, there is a start method. Inside the start method, the developer has written some lines of code, whatever it may be. And then last, or somewhere in the middle or something like that, the run method is called. Right? So when I call only the run method, what will happen? Only the run method will execute as a normal method. But if I call start, these lines of code which the developer has written, that will get executed first, and then the run method will get called. Because of these extra lines which the developer has written, which will get executed before the run method, because of that, the run method will execute as a thread. Is it clear? Shall I repeat? Please give quick responses.
No.
What about others? If you want me to repeat, please say yes. If you want me to repeat. Everyone has understood?
Repeat once again.
Huh. Okay, don't get scared or something. Okay, just tell me directly, repeat. Because it wastes a little time, right? I'm waiting for a response and all that. So what I said is, if you directly call the run method using the T1 or T2 object, it is possible because T1 and T2 are objects of your own class, and inside your class you have overridden the run method. So you can call T1.run, T2.run. But if you do like that, run method will get called directly as any normal method. But if you do t1.start, start is again a method which is available inside the thread class. And since your class is a child of the thread class, your class object can access the start method. Okay, there'll be no error. You can access the start method, which is available inside the thread class. So inside the start method, how the developer has defined, you have not defined the start method. Have you defined the start method? No, it is already defined by the developer. What he has done or she has done, he has already written some code here, and then internally he has written run. So whenever you call the start method, whatever is inside the start method will get executed. That means first of all this code will get executed, and then automatically the run method will get called. You can call one method inside another method. Okay, so because of these extra lines which the developer has inserted inside the start function, your run method, whenever it is called by the start function, it will act as a thread. Now is it clear?
Yes.
Okay, what about others?
Yes.
Yes.
Yeah,
Yes.
Sushant, Harshali, Abhishek, Mahendra, is it clear?
Yes.
Okay, yeah. So, and also see the output. See, when I call for T1 object, it will print happy cooking. And when I call for T2 object, it will print happy writing. So T1.start is called first. So you can see over here, what is the happy cooking, cooking, everything, cooking, cooking, cooking. Then see here, in between you got a writing. And also notice that you have two statements inside your run method. Which are those two statements? Your two statements are my thread is running for writing and happy writing. So out of these two processes also, some part only will get executed in between anywhere. So as you can see, my thread is running for writing. That means this particular has got printed. Happy writing has not got printed here. So between the steps written inside the run method also, they'll get executed. Some of them will get executed, some will not get executed. Okay, then again you have cooking, 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 everything cooking is there. And then again you have writing. Now you can see you have writing and then suddenly cooking. Then again writing comes. Then after some time again there is cooking. Again there is writing. And then again you have some cooking in between, again writing. So as you can see, though t1.start should have got executed completely and then t2.start should have got executed, what is happening? Little part of T1, then little part of T2, and they're exchanging. There is switching between the threads. Now, is it clear how it is happening?
Yes.
Yes.
Okay.
Yes.
Yes. Now, this is the benefit that all the processes will get executed simultaneously and no process will wait for another. Though you can make it wait, but let this normal implementation, this example which I showed you, they will not wait for each other. Okay, alternately or whenever possible. It depends on the JVM, Java Virtual Machine, how it will execute, which one it selects first, second. That is all dependent on the Java Virtual Machine. It may first of all pick T2 and then T1. That is also possible. In this example, first T1 and then T2. T2 and then T1 is also possible. Okay, and each time you execute, it will give you some different output. Not necessary in the same order. See, for example, initially the first thing was writing and then you had cooking. But now when I execute it, first is coming cooking and then later on you'll get writing. Okay, so as I said, the order is not constant. It will keep changing for different times you run your program. Is it clear till here?
Yes.
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 Okay, yeah. So this is one example, simple example. Okay, these are the 4 steps. These are compulsory for any implementation of multi-threading. Now, there is also something called as life cycle of a thread. So these 4 steps which are mentioned in this slide, because of these steps, you can define a particular life cycle of your thread. For example, First of all, when you create your object of your own class, that is say T in this case, I've created an object T of the test class. Test class is my own class, which is a child of thread class. So when I say T, when I create the T object, writing test T equal to new test, that time the thread is created. You can say the thread is born, thread is created because of this object creation. Then when you write t dot start, because of this method, the state of the thread is runnable. Now, runnable means the thread is ready to run. It is ready to execute. Now, the JVM will allocate the processor. Now, if you want to execute any process, that process has to be assigned to the processor of your machine. That is, processor means CPU of your machine. So, when there are so many processes, right? Not necessarily only the Java program. There are so many processes. So these processes are pipelined. They are put in a particular queue, and queue works on first in, first out. So whichever processes came early, or maybe on some priority, or maybe which process takes the shortest time to execute. There are so many parameters. Depending on that, JVM, Java Virtual Machine, will assign that particular process, whichever satisfies that criteria, to the processor. And now that process, which was runnable, which was ready to run, it will go inside the running state. Means now it is running. Initially it was ready to run. Now JVM assigned it to the processor. Now it is going to run. It is running. Okay, it is running. Now once it is finished running, that means all the 5,000 times the cooking is printed or the writing is printed, all the 5,000 times when its execution is over, that time its task is over. So it goes into the dead state. That means its execution is over. Okay, so these were the four states. First of all, it is created when you create the object. Then it will be ready to run in the runnable state when you call the start method. Then depending on the JVM, it will be assigned to the processor. It will then start running. It is in the running process. And then once everything is executed within the run method, its execution is over, then it will go inside the dead state. But it is not compulsory, as you saw that it will complete its entire execution in one go, right? We saw that some part was executed, then after some time little was executed, again after some time the next was executed. Now another possibility is that if inside the process you write some statement, like if you are using object dot the scanner object, okay, for example scanner object, why you use to take input from the user. So that time the execution will wait for the user to give some input, right? Am I right? It will wait for the user to give some input. Is it correct?
Yes.
Yes.
Yes. So that time what will happen? Unless the user gives the input, it will not go forward. So it is waiting for some input output device. Means, for example, it is waiting for some action to be performed through the keyboard. Okay. Not necessarily keyboard, maybe from some file, or maybe if you are using socket programming, maybe from some network connection. Okay. Java is not restricted to your own system. You may interact with multiple systems through the internet as well. That time you can accept input or give the output through the network connection through the socket programming. So that time you have to wait for network devices or some resources and all. So what happens, it may be running, then after 5 lines or something there is an input statement. So that time it will wait for the IO resource. IO means input output resource. Or maybe you want to give certain delay. You can give a delay by calling a sleep method. How you call the start method, or how you call the start method, like that you can call a sleep method. Similarly, you can call a suspend method. You can call a wait method. There are so many ways by which you can temporarily stop the processing of the thread. So in such cases, what will happen, from the running state, it will go inside the waiting state, or in general, you call it as the non-runnable state. It was in the running state due to some waiting, or due to some, it is waiting for some resource, or you want to give some delay intentionally. That time it goes into the non-runnable state. And once it gets the input, or once it is satisfied, then again it will not go inside the running state. First of all, after the waiting, it will go inside the runnable state. Means again it is eligible to run. And then again the JVM will assign it to some processor, and then again it will go inside the running state. Once it is in the running state, again it may go inside the waiting state. But after completing the wait, it will not go back to the running. After completing the wait, it will go into the runnable, and then the JVM will decide whether to make it again inside the running state or not. Is it clear? See, you can see the diagram
Yes.
also over here. After the running, it is going inside the waiting state, and after the waiting, it will go inside the runnable state, not inside the running state. And from the runnable, the JVM will decide whether to go make it go inside the running state or not. Okay, this means how it is. First of all, there is a creation, then there is a loop over here, means runnable, running, waiting, runnable, running, waiting. This loop will be performed again and again as per the coding that you have done, and then finally it will go inside the termination dead state. So the major processing happens inside this loop itself. Is this clear?
Yes.
Yes.
Yes. So you can compare this life cycle with the person's life cycle also. For example, the person is born, then he is eligible to study, suppose, then he's in a job, and then maybe he's nighttime, he'll come back from his work and he'll take some rest. That time he's in the waiting state. Then again he's eligible to go for his work. Then again he'll start working. And then finally, after all his processes are over, maybe he'll leave the job. Okay, so it is comparable with this life cycle of a person. Is it clear how this comparison I've shown you?
Yes.
Yes. So basically there are 5 stages. One is the when it is created, one is runnable, one is running, one is waiting, stopping, all those things, and one is the dead state. Now another thing, once you call the thread using the start method, it will perform its processing, whatever code is inside the run method. And after it is completed, it will enter the dead state. That means it is not alive. The thread is not alive. Now again, if you want to start the same thread, that is not possible. Means what? First time you write t1 t dot start, it will execute nicely, and then it is over. Again, if you do t dot start, it will not work. It will give you an error. That means the thread can be invoked or called only once. So if you try to call the same thread again, if you want to, means by start method, what happens? Your thread is created. Using the start method, your thread is created. After a person dies, can you make him alive again? No. That is same thing that is happening here. Once the thread is born, after its task is complete, it will be in the dead state. From there, you cannot bring it to the alive state again. Okay, so that is what is happening here. Using the start method, what happens? You can create the thread again. But once the thread is in the dead state, you cannot create it again. That is why you'll get an exception. And this exception is called as runtime exception. Runtime and compile time exception means compile time exception is where there are 2 phases. Once your program will be compiled, and if there are no errors, it will start executing. After you compile your program, suppose there are any errors, it will not execute. First of all, you have to remove those errors, and then it will start executing. So after you compile your program, if you get some errors, they are called as compile time errors. But suppose there are no errors after compiling, your program is running, you can see the output in the console window. You can see the output, but due to certain input that you give, for example, the best example to understand runtime errors is this one, divide by 0. For example, your program is going to perform the division of A and B. So A divided by B should be the output of your program. So now you have compiled your program. It has compiled successfully. Now you can see the output in the window. What you'll see, enter A, you enter the value 12. Then it will say enter the value of B. Suppose you enter 6 and then you click on enter, you'll get the output as 2. Am I right? Will you get the output as 2 in this case?
Yes.
Yes, you will get it. But suppose instead of 6, that is the value of B, the denominator, you enter 0. Then 12 divided by 0, it will try to find out what is the value of 12 divided by 0. But this is not possible logically. Okay. So for such inputs, the errors will be generated. Such errors which depend on how the user interacts with the program. Depending on how the user interacts with the program, the errors are generated. Such errors are called as runtime errors. Because if the user enters any non-zero value, if he enters 7, then also you'll get correct output. If he enters 9, then also you'll get correct output. But only if you enter 0, you'll get an error, and that error depends on how the user interacts with the program. So it is called as runtime error. But compile time error, what is the example? Suppose A divided by B and there is a semicolon. Suppose you forget putting the semicolon. Then when you compile the program, after that it will show you that semicolon not found. Some error message you'll get. So then you will have to put the semicolon and then recompile. And then there will be no error. Okay, so what I'm saying, semicolon or any syntax error. For example, you have an if condition over here and you forget to put the closing bracket. This particular bracket you forget. So this is a compile time error. When you compile your program, it will give you the error that's bracket is missing. But if the error depends on how the input is given, then it is called runtime error. Is it clear? The two types of errors, compile time and runtime?
Yes.
Yes.
Okay. So why I explained this is because when you try to create the thread again, when you try to start it, it will give you runtime exception. Means you compile your program, you won't get any error. But once you run, once the program is in the running, when it is running, when it is executing, that time you'll get an error. It is called, actually, the runtime errors are called as exceptions. Usually people don't say runtime error, they call it as exception, runtime exception. Okay, so same thing in the program, I've done it here. I'm calling the start method twice on the same thread. Same thread, why? Because on the same object, I'm calling that start method. So it will give you the error that illegal thread state exception. So the start, because of the start, what happens? You create the thread. So it is the creation phase of the thread. That phase cannot be called again. So that state is illegal. That is why illegal thread state exception. So there are different things that you can have. Now, okay. Now inside this thread class, you don't only have start and run method, you also have certain constructors and certain other methods and all. Okay. So it is not only that start and run are the methods, you have different methods. For example, these threads, as I mentioned, you can execute them based on their priority. For example, if you and always remember, if you say that you're not implementing multi-threading concept, that is false, because every program has at least one thread. Even if you don't implement multi-threading, every program has at least one thread, and that particular thread is the main function. Run is a method. Okay, run is a method that we have defined here, and that will be executed as a thread. Similarly, the main is a method over here that you can see, which is compulsory in every program. Without the main, you cannot run any program. So main is also a thread by default, as per the Java compiler, by the JVM, Java Virtual Machine. Main is also a thread. You mention it or you don't mention it, main is always a thread. So minimum one thread is there in every program. Okay, and if you want to specify the priority of these threads, there may be multiple threads. Other than this run method, for the example that we saw that there is myThread1 class in which there is a run method. There is another class myThread2 in which there is another run method. So there are two run methods, that means two threads, and there is a main method. So three threads in total. So in which order you want to execute these threads, you can specify. Otherwise, you'll get writing first and then cooking, or you'll get cooking first and then writing. You want to specify the particular order, depends on the priority. So first of all, if you want to check what is the priority, then you'll call the getPriority method. If you want to check the priority of a particular thread, priority means how important that thread is for the program. Okay, you can set that, and you can also understand that by default what is the priority. So if you want to check the priority, you must say, you can print thread.currentThread.getPriority. So thread is a class, and within that class there is a currentThread method, and by these two things, thread.currentThread, you will get the thread, you'll get the thread inside which you have called this. Means what? Inside the main thread, main method or main thread, inside this main function or method, whatever you call it, inside this main, I have written this particular statement. So current thread means main. For example, inside your run method, if you write thread.currentThread, then current thread will be what? Run method or run thread. Okay, so whichever method is there, inside that if you write current thread, it will refer to that particular method. For example, if I have another run method, and inside that I write thread.currentThread, then current thread means this particular run method. Is it clear? Current thread means which thread?
Yes.
Okay, so here current thread dot get priority. Now always remember, by default, the main thread or the main method, it has its priority as 5. Okay, and inside this main method, I'm going to create the thread of the test class. Right? Test is a class which I have defined, and inside that there is run method. To call that run method, I'm writing t.start. So I'm going to create this thread from the main thread. I'm going to create the thread of the test class from the main method. So the priority of the run thread or the run method, it will be equal to the priority of the main method. That means whichever thread is creating another thread. That means if you have a thread over here, T1, and it is creating T2, then the priority of T2 will be equal to the priority of T1. That means whichever child threads are there. For example, here T2 is the child thread. So this particular child thread will have its priority same as the parent thread T1. That is why if the main thread or the main method has priority 5, the run method also has priority 5. So when you try to get the priority, you want to display the priority of both these threads, main thread and run thread. It will give you the output as 5 and 5. Now you can also change the priority by calling the set priority method. What does get priority do? It will display the priority. And what does set priority do? It will set the priority. It will change the priority, or you can assign the priority. How you'll do it? Thread.currentThread, but this time dot set priority, and set the priority to 10, suppose. Yeah. Now, initially it was 5. So by this particular statement, the thread priority that will get printed will be 5. And then I'm changing the priority to 10. I'm setting it to 10. Now, if I try to access the priority by using get priority, will I get 5 or will I get 10? Yes, logically you can answer me.
10.
10. Okay. Once you change the priority, and after that, if you call get priority, whatever change you have made, that priority will be considered. Now you have set the priority to 10. Now, if you call get priority, the output will be 10. So the output for this program should be what? First of all, 5 will be printed. 5. Then set the priority to 10. Then again, the output of get priority will be 10 now. Okay. And then what you're calling the run method. And inside the run method, what do you have? Inside the run method, again, you're telling get priority. Okay. How the run method will be called? Can you tell me how the run method will be called? By which statement over here can you tell me that run method is getting called? Who calls the run method?
Start.
Yes, start will call the run method. So that is why I'm saying that when start is written, remember that always run will be executed. So inside the run, you're saying get priority. Now, as I said, the child's priority will be equal to the parent's priority. So what will be the output when I find out the child's priority? Yes. What is the priority of the main method? Can you tell me? Currently, what is the priority of main method? Yes. Your voice was not clear. Can you repeat?
10.
Yes, 10. So what will be the child's priority now?
10.
Yeah, 10. Okay. If I had not set it to 10, what would it have been? It would have been 5, because by default main method has priority 5. But now it is 10, so the child's priority is also 10. So 5, 10, 10. As you can see, that is the output. 5, 10, 10. Okay. Now, if I change the priority to 6 of the main method, then the priority of the child run method will also be 6. Similarly, I can set the priority of the child also. Now here, if I don't want the child to have the priority same as the parent, right? I want the child to have some other priority. Then I will say current thread dot current thread dot set priority, and then I can pass suppose 7. Now if I say get priority, the priority has been set to 7, so get priority will display the priority as 7. So you can change the priority of any method. Now you may be wondering, I'm setting the priority to 6, 10, 7. Is any integer possible? Suppose I say 100, suppose I say 1000, suppose I say -1. Is any integer possible? No. The specific integers are only possible, and the range is either the priority can be 1 up to 10, between these numbers only. Okay, the priority can be between 1 to 10 only. Now there are certain constants. Instead of always writing 1, 5, 10 or something, what you can do is you can write certain constants, like you can say suppose thread dot set priority. I'm writing some short form here, sp set priority, sorry, thread dot current thread, thread dot current thread dot set priority, and inside the bracket I will not pass any integer, but this time I will pass max underscore priority. Okay, max underscore priority. The value of this constant max priority is 10. So whenever I write max priority, it will take it as 10. If I write min priority, it will take it as 1. If I write norm priority, it will take it as 5. That means if I write max underscore priority, this is the way to write it. Okay, if you miss the underscore, it will give you an error. Max underscore priority, its value is nothing but 10. Similarly, min underscore priority, its value will be 1. And if I say norm, norm, norm means normal, norm underscore priority, its output will be, its value is 5. So the main method's priority is what? By default 5. That means it is at the norm priority. Is it clear till here?
Yes.
Okay, so there are some other methods, and I'll just discuss this concept. There is something called as Daemon Thread also. Daemon Thread means these particular threads keep executing in the background of your actual thread. For example, you consider your word processor, your Microsoft document, Microsoft Word. There what happens, if I type any spelling in an with the incorrect spelling, if I type any word with the incorrect spelling, for example, I make a spelling mistake in welcome, automatically it corrects it. I'll show you again. What I'm writing, welcome R. If I write space, if I hit the space key on my keyboard, it may show an error like this, or like the previous time, it directly corrects it. So what this error message is telling, it will suggest me, or I can change it to ignore or whatever. So what is your main thread here? Your main thread, your actual thread that you are interested in is typing. The process of typing, you want to do it. Welcome, whatever, you can keep typing. This typing process is a thread. Now, in the background, which process will run? The spell checking or the spelling correction process. It is happening in the background. Am I right?
Yes.
Okay. So this background thread, which is running in the background automatically, it is called as daemon thread. Okay. So you can create your own daemon threads also. For example, if you want to define the functionality of typing, and if you want to define the spell checking functionality, then what you'll do, your typing functionality will be the actual thread, and in its background, you will create a daemon thread, and that daemon thread will do the spell checking. Okay. You can also implement it. And here are some points, but in the interest of time and all, I will not discuss it. In future, if advanced concepts are there, that time we'll discuss it. Okay, so this is quite a long topic. I thought I'll finish it soon, but anyways. So similarly, you can use a runnable interface also. What the runnable interface will do is same thing as you can do with the thread class, but there are some benefits. the runnable interface Okay, so here there's an example of how you'll use multi-threading by the runnable interface. So if it is an interface, your class implements runnable. And this also has the run method. Same thing you have to do. You have another class in which there is another run method. Okay, in the first thread, what it will do, I am thread 1 will get printed for these many number of times. You can put this inside a loop also. And here it will print I am thread 2 if it is the second thread. So there are two threads because there are two run methods in two different classes. Now, first of all, what you'll do, you will create an object of your own class, suppose bullet1, and this object or this reference, you can say bullet1 is referring to the object of class 1. My thread runnable 1 is a class which you have defined, and the bullet object or the bullet reference, using bullet1 reference, you're going to access the object of this my thread runnable class. Or you can simply say bullet1 is the object of my thread runnable 1 class. So using this object, you have to do something. This object has to be passed as a parameter to the constructor of the thread class. What I said, you have a thread class also, right? But in your previous examples, what you are doing, you are creating a child of your own class, and your child was a child of the thread class. Okay, you are creating an object of your own class. But now I'm creating an object of the thread class called as gun1. Okay, thread class ka object I have created. And whenever I create an object, what happens? Constructor will get called, and you can pass a parameter to this constructor, means parameterized constructor, and the parameter will be the object of your own class. Means you have to create an object of your class also, and you have to create an object of the thread class also. And your object you have to pass as a parameter to the thread class. Is it clear?
Yes.
Okay. Similarly, for the second class also, I've done that same thing. I have created an object and created another object of thread class and passed bullet2, which is an object of your class, as a parameter to the thread class object, to the constructor. Now, using the objects of the thread class, you will call the start method. That is gun1.start, gun2.start. Now, why using the object of the thread class only? Because this start method is not available in the runnable interface. As I showed this slide already, there are constructors, method, run, start, all this is in the thread class, and inside the runnable interface, only run method is there. That is why you have to take the help of thread class if you want to create the thread by calling the start method. That is why object of the thread class dot start. And then you'll get the same things. That means sometimes what it will print I am thread 1, and then sometimes it will print I am thread 2, again it will print I am thread 1, again I am thread 2. Okay, same thing will happen, but only the way of creating the thread, implementing this is a little different. Have you got this way also of doing it? Is it clear?
Yes.
Okay, now what do you think, which is a better method, using the thread class or is it by using the runnable interface? What is your opinion? You can tell any answer, not necessary that you know the reason, just whatever you feel. Maybe you may say in the way of creating is which is easier or something like that, which is preferable to you. Yes,
Runnable
just say.
interface.
Okay, any other answer? Mahendra, what about you? Am I audible? Hello? Yes. Anyone wants to give an okay, Runnable. Now the correct answer is Runnable. Yeah, that's right. But what made you think Runnable, Pratik and Mahendra? Mike is not
because
okay. Okay, yeah.
the parent class is not involved in that. Means we are not creating the object of thread class.
Uh, okay. Okay. So actually, there's one very good reason for this. I'll tell you. Creating an object and which you're creating an object of thread class, or you're creating an object of your own class, or you're using runnable interface, that all is okay. There'll be no change in the efficiency of your program. Okay, but the main reason is, suppose you have your own class, that is, I'll call it your class or my class, whatever. And if you're using thread class, what will do? Extends thread. Now suppose you're using the runnable interface, then you'll write my class implements runnable. Now suppose your class, my class, okay, my class, if it wants to be a child of another class, okay, my class wants to be the child of another class also, then in which case is it possible? Is it possible in case 1 or is it possible in case 2? I want to have multiple parents. Is it possible in case 1 or is it possible in case 2?
Case one,
Why case 1?
Two.
Yes, case 2. Okay. See, we have learned that if we have extends keyword, means we are having inheritance between classes. Now, is it possible for one class to have two parents? Can I write here comma and say parent one, suppose? Is it possible in to have, means how this is represented diagrammatically? If I draw the diagram, inheritance relationship diagram for this, it will be something like this. I will have a thread as the parent, I will have parent one as the parent, and their child will be my class. Which is this diagram? This particular diagram is for which type of inheritance? Yes, we have seen inheritance types like single, multiple, multi-level, hybrid. Which is this type of inheritance? It is multiple, right? And what is the problem in
Multiple.
multiple? What is the problem in multiple inheritance? I have mentioned this multiple times. If you have the same method in thread class and the same method in parent class, it will give you confusion for the child class, right? Am I right? Yes. So, though the methods may be different in the thread and parent one class, it will never allow you to create multiple inheritance. But to solve this multiple inheritance, which concept we used?
Interface.
Yes, we have used interface. So in the second case, we are using runnable, which is an interface. So here you can have multiple parents. That means you can have multiple interfaces as the parents. You can have parent one, comma parent two, comma parent three, and so on. And you can have minimum one class as the parent. You can write extends parent, and then minimum one class only is possible, because if you have two classes, three classes, it again becomes multiple inheritance. So minimum one class and any number of interfaces. So this is more flexible, right? Case 2 is more flexible. Am I right?
Yes.
Yes. So in case 1, in real-time applications, we know that so many classes will be sharing the properties. That means so much of inheritance is required. So it is definitely not possible to use case 1 in real-time applications. For small programs, you may use it. But for such real-time applications, always go for interface method of creating multi-threading. So this was the main reason. Now is it clear for everyone?
Yes.
Yes.
Okay. So this, whenever you study any concept, right, you need to know why it is like this, so that you remember it for a longer time. Otherwise, you simply think that, okay, this is better. No, this is not better. You may forget it because you don't know the reason why this is better and why that is not. If you know the reason, you will remember it for a longer time. Okay. So there are some more methods that you can call for your thread objects. For example, constructors in case of threads. Now, consider that you're using the thread class for the multi-threading. You're not using runnable interface, you're using thread class. Now what you're doing, you will create object of your own class, and you'll call the start method on that object. Now, every thread has a particular ID. And if you want the ID of that thread, how you'll do it? You'll call the getId method on that particular object. Similarly, you can call a getName method on that particular object. When you say get ID, whatever ID is given for that particular thread by the JVM, that will get displayed. And when you say get name, whatever you pass as a parameter at the time of object creation, you have created objects of your thread classes. So those objects, while creating, the constructor will get invoked, will get called, and for that constructor, you're passing some names like Nitesh and Bob. So whenever you say get name, whatever name you have passed at the object creation, that will get displayed when you say get name. Like when we are saying get priority, the priority was getting displayed. So when you say get name, the name will get displayed. When you say get ID, the ID will get displayed. Similarly, get name, you have set name also. So what will set name do? It will change the name that you have given for that thread. So you can name your threads, okay? Because what happens, using IDs is okay, but if you give the threads particular name like thread 1, instead of Nitesh or Bob, I can say thread 1, thread 2 also. So if you give such names, it is easier for you to know which is that thread, because there may be multiple threads in your program. So if you want to change the name in between somewhere, you can say that particular object dot set name. And then when you call get name, you will get the new name that you have set. For example, here I'll get my name, Joel. Okay. Similarly, for thread 2 also, you can change the name. You can set the name to something else anywhere in your program, means after you've created the object, and then you can call get name. So I'll run this program. So IDs are what over here? It is 15 and 16 in this case, whatever the JVM has given. And then this was the name that I passed at the object creation. Then I've changed the name. If I change the name and then I call get name, the updated name will come. Okay. So is this clear now, this particular program also?
Yes.
Okay. And yes. So another concept is thread joining. Okay. There are some more methods. For example, is alive means you're checking whether the thread is alive, it is not in the dead state. Okay, means sometimes what happens, if it is not executing, means it may be in the waiting state or suspended state, but it is alive, it has not reached the dead state, so that you can check using is alive. And another concept is joining. So for example, join means what? Suppose consider there are two threads, thread 1 and thread 2, which we have created in our program. So this is suppose thread 1 and this is another thread 2. Now you were seeing that sometimes thread 1 is executed partially, then little bit of thread 2, then thread 1, thread 2 and all that. If you want thread 2 to wait for the complete execution of thread 1. And one more thing, the priority concept that we are doing, get priority, set priority. So if the priority that you set is max priority, that means if the priority is 10, if the priority is 10 means it is the most important thread. That means that thread will get executed completely, and then the remaining thread will get executed. The other threads will get executed. Okay. And if it is min priority, then that particular thread will get executed last. You will not see it executing in the between or in the beginning. Okay. So that is the meaning of max priority, min priority. Norm priority means somewhere in the middle it will keep executing. Okay. Now is it clear why we are doing set priority, max priority? Is it clear? Yes.
Yes.
Okay, so that was priority. And one more thing, if you run those priority based programs, if you set the priority to max, it is very possible that you will see it executing in the beginning. You'll see it executing in the end also. Means what? If it is max priority, then only in the beginning it should execute and it should finish, and then the remaining threads will execute. But it is possible that you will see it executing towards the end also, though it is having the maximum priority. Because if you are having a Windows machine and you're running such programs, Windows does not support the priority concept. Okay, what I said, Windows does not support this setting and getting of priorities. So the JVM, whatever priority it gives, and whichever order, little bit of thread 1, little bit of thread 2, switching between them, that will happen, though the priority may be maximum or minimum. Is it clear? For Windows, threading priority will not work. Is it clear? Yes.
Yes.
Okay,
Yes.
for other systems like Linux, Mac and all, it will work. Whichever has maximum priority, that will execute first, minimum priority will execute last. Now, joining is a similar thing to priority, but it's a little different. If you want thread 2 to wait for the thread 1 to complete its execution, okay, means thread 2 should execute only after thread 1 is completed. For example, in your interview rounds, what are your interview rounds? For example, first of all, you have aptitude based round, then you have a technical based round, and then finally you may have some HR round. Okay, so can the technical round be conducted before the aptitude round, or can the technical round be completed along with the aptitude round simultaneously? Is it possible?
No.
No. That means what? Technical thread will wait for the aptitude thread to complete, and based on whatever execution has happened, the technical thread will run. Similarly, HR thread has to wait for technical thread to complete. Okay, that is a real-time example where these threads have to wait for each other. Is this example clear? Have you understood why one thread has to wait for another thread?
Yes.
Okay, so you can make one thread wait. That is, suppose thread 2 is waiting for now. Currently, thread 2 is waiting and thread 1 is executing. Okay, thread 1 is executing and thread 2 is waiting for thread 1 to execute completely. Once thread 1 is executed completely, thread 2 has to join the thread 1. Okay, thread 2 will join thread 1 after thread 1 is completed completely. Means technical thread will join the aptitude thread once the aptitude thread is complete. HR thread will join the technical thread once the technical thread is complete. So this join method will help you to make one thread wait while the other is executing, and then thread 2, which was waiting, will automatically join the thread 1. So you can sequence or decide the order of your execution of your threads. Is it clear?
Yes.
Then this is some life cycle that I've already told you: runnable, running, terminated, waiting, blocked. And these waiting and blocking and all, you can perform it by calling certain methods also, like yield, time, terminate, wait, join, suspend, sleep. Okay, that is some other concept. Then you can synchronize your threads also based on certain methods. Okay, those are some concepts which we'll not touch now. We'll see them later. Okay. So is there anything else that I want to show you? Let me just check. Okay, so any doubts you can ask me, and if no doubts, you can put your attendance in the chat box and you can leave this meeting. Thank you.
Thank you.
Welcome.
Thank you.
Welcome.
Thank you.
Thank you.
Welcome. Welcome.
Thank you.
Welcome.